Wind power, together with solar power and hydropower, represents today the three main pillars of renewable power generation. They cover approximately 25% in the average of the power mix in the grid. Future plans provide that these technologies will increase to a share of approximately 50% by 2050. Wind power is an important renewable power generation technology, allowing to reduce the emission of CO2 in electricity production. Wind power is one of the most established technologies, and we have the infrastructure of building up these wind parks. Renewable power generation technologies are extremely raw material intensive. We need, for instance, lots of metals to create the structures and the equipment that generates this power. Especially windmills are very steel intensive, and in order to limit the use of steel, we go to higher strength steels, where molybdenum is a key alloying element providing this property and performance of a steel in this application. Windmills have been increasing in size over the last 20 years, from early models having 1-2 megawatt power output to the more recent generation in the order of 10 to 12 megawatt power output, and in the future 15 to 20 megawatt power output. And that means rotors are getting bigger, torques are getting higher, loads on components are getting higher. And this can only be counteracted by going to higher strength steels, where molybdenum is one of the key alloying elements. In a wind turbine, you have a powertrain that converts the low RPM on the rotor side into a higher RPM at the generator side. And essential to do this is a gearbox. This gearbox transmits the torque, the forces from the rotor, and creates the RPMs that drive the generator. These gears are made from steel, from a very special steel, so-called carburizing steel, that is principally alloyed with chromium, molybdenum and nickel. There is an alternative technology that works without gearbox. That's the so-called direct drive technology, where magnets play a major role in generating the power. So you have actually a generator with a high number of permanent magnets. And these permanent magnets require a large amount of rare earth metals. There's only a few countries who produce these metals, and most of all China. So there's a high dependency of any turbine producer in the world securing this rare earth metal from China. So these rare earths are costly, and also for larger wind turbines that we are constructing today, these converters are becoming exceptionally big. So here the gearbox can offer a better alternative. And molybdenum is essential to increase the performance and durability of such gearboxes. Traditional high-performance gear steels, so-called case carburizing steels, are typically alloyed with 0.2 to 0.3% molybdenum. However, in the application of such steels in high-performance wind turbines, we have often enough seen early failures of the gearboxes. Due to that, we have been doing a project with IMOA and some industrial partners and a leading university in gear design to see if there are better alternatives with better performing steels using higher amounts of moly. And indeed, the project has been showing that when we increase the molybdenum content up to 0.5 or maybe even higher, we get a substantial improvement in the performance of gears under very high loads. So here we actually develop an alternative to to existing gear steels, and of course also an alternative to gearless wind turbines or so-called direct drive turbines. The typical parts where molybdenum is used in wind turbines is in the powertrain. So shafts, gears, bearings. These are traditional quench and tempered steels and also the so-called case carburizing steels. So that is established, but with increasing size of the windmills, we might have to look into other opportunities of reducing the weight of the components. Since molybdenum is an alloying element that produces strength like few others, its position will be very important to produce the necessary materials for renewable power generation, for making the equipment that installs renewable power technologies. The forces and torques that are transmitted into a gearbox are becoming much higher. However, we cannot make the gearbox increasingly bigger due to constraints in space and also due to limitations of lifting weights. The higher amount of torque needs to be handled by the same amount of material. That means the torque density, that is the torque flowing through 1 kilogram of material, becomes much bigger. And that requires steels to become more performing. And these upgradings of the steels to higher performance can be indeed achieved by increasing the amount of molybdenum alloy to these steels. Renewable power generation technologies are very raw material intensive, very steel intensive. Wind power industry has a very high specific need for steel. One of these metals is molybdenum, that is rarely used in pure form for such technologies, but heavily used as an alloying element to make the respective steel and casting alloys for these technologies. Detailed analysis of components in a wind turbine and the related moly content indicates that approximately 100 to 120 kilograms of molybdenum per megawatt of installed power capacity is a good value. By this amount, we would need approximately 1 complete year production of molybdenum, realize all the wind turbine capacity until the year 2050.